All right, friends, in this video lesson, we're going to talk about percent applications. So we already did some work early in the year on doing percentages, so we're going to revisit that. We're also going to be looking at, in this section, percent increase as well as percent decrease. So the first thing we're going to do is just go back and revisit the basic percentage of a number. So how do we find a percent? So a percent, again, is just a way of looking at an amount of a specific quantity. It kind of relates back to fractions and ratios that, for example, if I were to have in its fraction form, say 4 out of 8, what I can do is express that as a decimal. 4 out of 8 would be 0.5 or 0.50, if you will. And then as a percent, what we do is express that out of 100. So 0.5 would be like saying 50 units out of 100. Or we could express it as 50%. So we look at a percent, it specifically talks about the chunk or the amount out of the whole. So the way we're going to kind of establish a percent is we're going to look at it this way. We have essentially three things. You have the percent. Think of the percent as not as the percent, but think of the percent as the amount of the whole. The whole is going to be the base. So think of this as the percent based on the base. And we can express that then as a rate. And we're going to think today as the rate as the percentage. So the percent of a number is just simply the rate times the base. So if I wanted to find, hey, what is 20% of 100? 20%, this would be considered my rate, and the 100 be considered my base. So if I want to find a percent of that, what I'm going to do is just take the 20%, which is my rate, and times it by the base. Now, just know, again, that when we work with percents in problems, what we need to do first is change that percentage to a decimal, or that rate, I should say. So 20% would be 0.20, or just simply 0.2. If I multiply that then by 100, that would give me my percentage, which in this case would be 20. So we could say that 20 is going to be our percent based on the rate of 20% and the base of 100. So the way we're going to look at it today is based on the rate and the base in order to find the percent. All right, so let's go through some examples. In example 1, just going to do some basic things with percentages here. The first one says, what is 5% sales tax on an item that costs $240? So again, we're going to find the percent. So we're going to use our percent equals rate times base. Our rate here is the percent, so 5%, which written as a decimal would be 0.05. Again, all percentages are out of 100, so in terms of changing this percent to a decimal, just simply divide it by 100, and that would give you 0.05. Some of you also know to move the decimal 2 spots to the left when you are going from a percent to a decimal, and we could always go the opposite way and move it 2 spots to the right if we were going from a decimal to a percent. So my rate, again, is going to be 0.05. My base then is the amount of 240. So 0.05 times 240 would give me a percentage of 12. So in this case, I would have 12. And unit-wise, it would be $12 since our original base quantity was $240. So $12 is the percent when our rate is 5 and our base is 240. Next one says a cheap high school student leaves a $2 tip on a bill of $250. What is the percent tip? Now, this one's a little tricky when I say what is the percent. The thing that I'm asking you to find, so here notice that I don't actually give you the percentage here. So what this is referring to, is the rate. So what is the percent tip? So I want to find the rate. So again, using our formula, percent equals rate. So it's going to equal our rate times base. In this case, our percent is going to be a $2 tip. Our base is $250, and our rate is unknown. So if I, in this case, want to find the rate, what I'm going to do is take my percentage, which is $2, and I'm going to divide it by the base of 250. What that would do is tell me my rate. In this case, my rate would be 0.008. Okay, now expressing that as a percent, if I were to move this decimal 2 spots to the right, or what I could do is take this in the end and multiply it by 100 to turn it into a percent, you would get 0.8%. So that cheap high school student didn't even tip the waitress or waiter a 1% tip. Classic. Okay, so what we're going to do is, again, use this percent formula, P equals R times B. And I can use this formula to find the percentage, which is our kind of our output, our rate, which is our percent, or even the base, which is what we're starting with. So this next one says a company's annual profit was 130% of what number is 97.5. So you're given the 130%. So 130%, think of that as our rate. Okay. Now it says of what number is 97.5. So when it says the of, that's going to represent our base. So in this case, the base, we don't know. And the is a good indicator of what the percent is. So in this case, the percent of our base is 97.5. So to find the base, we're going to use our formula, P equals RB. My percent, is 97.5. My rate is 130%. Now, as a decimal, that would be 1.30 or 1.3. Again, I have to divide by 100 or move the decimal. So I'm going to put 1.30 as my rate, and my base is unknown. So I'm going to put B right there. So again, this kind of goes back to our very first example when we're trying to find the rate. In this case, if I just divide by 1.30, it will tell me what my base is. And I would get a base of approximately $75. Now notice here that my base is smaller than what my percent is, and that is because the percent, you'll notice here, is bigger than 100. So that means the percentage, the end result, is actually bigger than what we are starting with. If your percent is less than 100, you would get a number that's less than that amount. Okay, so a number that's greater than 100% means that we're getting bigger. All right, next one says an engine lathe is billed at $1,960 with a 2% discount if paid within 30 days. I want to know how much is saved if it is paid within 30 days. So here you are given the amount, $1,960. Think of that again as the base amount. You are then given the percent off, the discount of 2%. That's going to represent our rate. So I know in this case that my percent is what we are trying to find. The rate is given me as 2%. My base is $1,960. My percent, or my rate, I have to change to a decimal, so 2%. And I can divide by 100 or move the decimal, would be 0.02. Then finding the percent of that number, P equals RB, I'm going to take 0.02 and just simply multiply it by 1,960. And that would give me as an answer, my percent would be $39.20. So $39.20. That's how much money we would be saving with that 2% discount. Not what we'd be paying, but that's what we'd be saving. All right, so let's have you try these next two examples on your own using, again, the percentage equals the rate times the base formula. For each of these, might help to write out what is your percentage, what is your rate, and what is your base, and then go ahead and solve for the unknown value. So try these two on your own. And here we go. So the first one, recognizing I give you the rate of 1.5%, you're given that there are 84 that were found to be defective. So that would be the percentage. So in this problem, you're trying to find the base. So plugging those values in and dividing by your rate, you would get a base of 5,600 nuts and bolts. So of those produced, 84 were defective, and that would be about 1.5%. Next one, you're looking for the percent efficiency. So this is actually because you're finding the percent. Again, a little tricky here because we're using that word percent to represent our output, but here you're trying to find the rate. So your output would be 96 watts. Your base, in this case, your input would be 108 watts. So trying to find the percent, if I divide by 108, I would get 0.8 repeating. So I rounded that to 0.89, which is 89% efficiency for this electric motor. All right, these first couple examples, just looking at how to use that base application of percent based on the rate and the base. Our last four examples we're going to look at is not just simply percent in its basic form, but we're going to look at percent increase versus percent decrease. So for example, if I were, let's say, go to Kohl's and I was going to use a 30% off coupon, the 30% off is going to represent the amount of money taken off the original price. But what is that going to allow me to pay in the end? So for example, let's say that I was buying something that was $100 and I had 30% off. Okay. Well, 30% of 100 is $30. So that would be $30. Now, $30 is not what I pay, but $30 is what is going to be taken off. So in the end, what I would end up paying is I actually pay $70. So I start here. My percent tells me how much is taken off, which would be that amount, and then I end there. So what we're going to do is solve problems like this. This would be a case of a percent decrease because I'm taking values or amounts away. And we're also going to look at the same thing, reverse of a percent increase. Now, the way we're going to do this is like this. When I look at my original value of $100 and compare it to 70, you'll notice that, okay, if I took 30% off, here's the way to think about it. This is 100% of the price. Taking off 30% means I pay $70. Well, $70 is just simply 70% of what the original price is. So when 30% decrease represents a 70% overall value that I would be paying. Same thing is true if I were to look at percent increase. Let's say that something increases by 30%. Well, I would take 30% of that value and add it on. So instead of looking at 70%, it would end up being the opposite. Add it to 100 would be 130%. So here's the way we're going to look at this. Okay, the formulas are looking a little bit different, but you have your amount based on your principal, your starting value. And notice it says here 1 plus R. R is going to represent your rate. So R is going to be your rate, and it's going to be your rate as a decimal. So you notice here that I have 1 plus R for increase and 1 minus R for decrease. Where's the number 1 coming from? 1 is going to represent 100%. So 1 equals 100%. So if I, let's say, had a discount of 30% off, that would be a percent decrease. I would do 1 minus or 100% minus 30%, which would give me 70%, and that's what I'd multiply back on. If it was percent increase, I would add that 30% to the 100%, and that would tell me how much I'm multiplying to make it bigger. So let's take a look. So here we have a company sells a new tractor for $5,000 and offers a 30% off discount. Okay, so when you see a 30% discount, that's going to be a percent decrease. Okay, so here's how I'm going to set this up. I'm going to use the formula A equals P times 1 minus R. So the A is going to be the amount that I'm going to pay in the end. P is going to represent, call it the principal, what we're starting with. The tractor costs $5,000 to start. Okay, now what I'm going to do is I'm going to multiply it not by the rate itself, but what I'm going to do is I'm going to take the rate off of 100. So 1 minus R, my rate is 30%. So the way I'm going to write that is 1 minus 30% as a decimal, which would be 0.30. Okay, now simplifying this, 1 minus 0.30 is 0.70. So I have A equals 5,000 times 0.70, which says if I'm taking 30% off, I'm paying 70% of the original price. And that amount that I would end up paying then would be $3,500. So $3,500 is the amount I would pay for that lawn tractor. Okay, next one, it says that the floor space is to be increased. So 14,000 square feet is to be increased by 20%. What is the new amount of floor space? Now here we have a percent increase. Okay, so I'm going to set this up the same way. We have 14,000 square feet. So using my formula, A equals P times 1 plus R, since we're looking at increase, my original amount is 14,000 square feet. So I'll put 14,000 times 1 plus my rate of 20%, which would be 0.20. So what is this going to look like again? That's going to be $14,000 times 1 plus 0.20 is 1.20, which as a percent would be like 120%, which means that it's going to be a larger value. So multiplying those together, my value in the end would be 16,800, in this case would be square feet for that floor space. So percent increase and decrease, all we're doing is taking our percent and either subtracting it from 1 or in the second example, adding it to 1. All right, last two examples here, we're going to use the same idea of percent increase and decrease, but now we're going to solve for one of the other variables within our formula. So again, we're going to be using those same two formulas before based on whether it's percent increase or decrease. In this case, first example is discounted 30%. So an item's discounted, the customer pays a total of $585. What's the original price? So this is a percent decrease problem. So I have my amount equals my principal times 1 minus R. I know that the amount I'm paying for A is $585. The principal or the starting amount is what I don't know. And I also know my rate is 35%. So I would do 1 minus 0.35. Okay, so all I got to do is solve this for P. So here we go. We'll first want to simplify this. 1 minus 0.35 would be like 585 equals P times 1 minus 0.35 would give us 0.65. And then lastly, what I'm going to do is just simply divide both sides by 0.65. Oopsies. Okay, dividing this number by a decimal is going to give me a large amount. In this case, since it is a percent decrease problem, my original value should be bigger than what my final answer is. So in this case, my principal or my starting amount would be $900. Okay, so we're just using this formula in reverse to try and solve for one of the values. All right, next one's going to be a little sassy. It says find the percent increase. So company's profit increased from 1.65 million to 1.72 million. So percent increase, we're going to use the formula A equals P times 1 plus R. Where we are starting from is we are starting from 1.65. So think this is P. This is the amount of increase at the end. Our goal is to find the percent. So we're going to try and find R in this formula. So I'm going to plug my values in. My amount in the end is 1.72 million. I don't have to type in the full numbers. I'm just going to use 1.72, starting at 1.65. Times 1 plus R. Now, how do I solve this first? The thing I'm trying to solve for is inside the parentheses. So the first thing I'm going to do, I don't want to distribute here, but I'm going to start first by dividing by 1.65 million. That's going to cancel those out. And what that's going to give me in the end, I'm going to round this to the nearest hundredth. I would get 1.04 equals 1 plus R. Okay, so 1 plus R is 1.04. Now, the way to think about this, I guess algebra, we can solve this by just simply subtracting 1. But remember, for percent increase, we always add on the rate. So my 1 plus R, if I just simply look at 1.04, that 0.04 would represent the percent increase or the rate. Mathematically or algebra-wise, what I can just simply do is just subtract 1 from both sides, and that would give me 0.04 equals my rate. So the rate of increase in this case would be 4%. Okay, so that one just a little bit extra work in terms of the algebra to solve that. Again, it's just comparing it to that number 1, whether it's bigger or smaller for percent increase or decrease. All right, so this is just a revisit of percent applications, but also looking at and adding into it our percent increase versus our percent decrease. If you have questions, make sure you bring the class. Good luck on the practice, and we'll see you next time.